So we started off with graphs. These were linear graphs, and we just put the values of x, substitute values of x. Sometimes they're given, sometimes no. And then we plot the points x and y and draw the straight line. Then there was another practice exercise, new topic, that is coordinate geometry. So then the first subtopic of coordinate geometry was gradient of the line. The gradient is y2 minus y1 over x2 minus x1. Do you remember this?
Yes, sir, I remember this one.
Let's do one question as practice. I'm going for number 5. So in that the coordinates are given 7 comma 5 and the second coordinate is 1 comma 6. So y2 minus y1 over x2 minus x1. 6 minus 5 is 1. 1 minus 6, 7 is minus 6. So this is our gradient. And then we had midpoint. Formula for midpoint was x1 plus x2 over 2 comma y1 plus y2 over 2 bracket. Same question again. Do you remember this?
Uh, I, this one is, yeah, I remember this one.
Let's say we solve number 6 and the points are given as 7 comma 5 and the other one is 1 comma 6. So x1 plus x2 over 2, y1 plus y2 over 2. 7 plus 1 is 8, 5 plus 6 is 11, so 8 by 2 is 4, and this is 5.5. Whatever you do, keep it in exact form, either fraction or decimal or mixed number. Do not round off. So these were midpoint and distance for the same. Distance formula was x2 minus x1 whole square plus y2 minus y1 whole square root. So if I'm using those same points, x2 minus x1 whole square, y2 minus y1 whole square root. So this is 7 minus 1, 6 square and minus 1 squared. Obviously, it would turn out as positive number. And the final answer is square root 37. The question said leave it in surds form where simplification is not possible. Okay. Now just try this. This is a twist question. Actually, the midpoint is given and the end point is missing. Question number 13. Is it readable?
Okay, sir. Yes, sir, I can read it.
Question number 13. Still doing?
Yes, sir. I'm still doing.
Okay.
Sir, I'm not getting it.
Okay.
Uh,
See, the question says the end of line segment is minus 2, 3. This is minus 2, comma 3. And it says the midpoint is 3, 1. And find the coordinates of the point of the other end. Let's say this is just a sketch. Even if we don't draw that, we know that these are the 2 points and this is the midpoint. So basically formula is x1 plus x2 over 2, y1 plus y2 over 2, and this will give us the midpoint, which is clearly 3 comma 1. I'm just substituting the values. First value is known, minus 2, the other is unknown, over 2. First value is known, 3, and other is unknown, over 2. See, x1 and x2. Then we are getting y1 and y2. Now this is equal to the given midpoint. This time the coordinate is missing and midpoint is given. So x coordinate equal to x coordinate and y point equal to y point. And now we solve. Minus 2 plus x is equals to 6. S is equal to 6 plus 2. So x is equals to 8. And on the other side, 3 plus y equals 2. Y is equal to 2 minus 3. Y is equal to minus 1. So the new point is 8 comma minus 1. So basically, when we had minus 2 comma 3 and new point is 8 comma minus 1, midpoint of these two is 3 comma 1.
okay. Uh,
Let's try number 14 as well. I gave this to Ali as homework. 14 says the distance between the points xx and 10 comma minus 10 is this. The first point is x comma x. The other point is 10 comma minus 10. And the distance is 2 square root 122. Find the two possible values of x. And the distance is given. We just need to put it in the distance formula. So let's say distance is x2 minus x1 whole square plus y2 minus y1 whole square root. So the distance is already given. I can substitute 2 square root 122 is equals to square root using those values. X2 minus x1. Let's say this minus this, x minus 10 whole squared plus y2 minus y1 whole squared. And then I do square root on both sides, square on both sides to get rid of the root. This is 4 into 122 is equals to the root cancels out. This is a square plus b square minus 2ab. And this is minus minus plus. So that's a square plus b square plus 2ab. So we simplify, getting rid of these two. I'm having 2x square plus 200, and on left hand side it was 122 into 4 is giving me 488. So 488 minus 200 is 288 is equals to 2x square. 288 by 2 is 144 is equals to x square. Square root both sides. X is equals to plus minus 12. So possible values are 12 comma 12 or minus 12 comma minus 12. That was use of distance formula. I'm thinking we should move on or practice the previous exercise. What
I
do you
think
say?
I understand now.
Sorry, I didn't get it, Haris. Can you please repeat?
Yes, sir, I was saying I think now I understand.
Okay. Okay, let's see. New exercise. It is equation of straight line. What would be there in equation of straight line is y equals mx plus c. This is exactly the same form we've been using to draw the graph of straight line. Now we have to find the equation of straight line. So what happens is y equals mx plus c. We need the gradient, we need the y-intercept, and then we can find the equation. There will be different types given. For example, the one question says that the gradient is 3 and y-intercept is 4. So we can write y is equals to 3x plus 4 and equation is done. The second could say that the line passes through 2 comma 2 and 5 comma 7. So we'll need the gradient first, that is y2 minus y1 over x2 minus x1. So using the same coordinates, this is 7 minus 2 over 5 minus 2 is 4 by 3. This is the gradient. So y is equals to 4 by 3x plus c. I need to find c. We can use any coordinates out of these two. I'm using the first one, where y is 2, x is 2, and I can find c. So 2 minus 8 by 3 is equals to c. 6 minus 8 by 3, c is equals to minus 2 by 3. Once we are done, we can rewrite the equation y is equals to mx plus c. Now this is acceptable, and you may wish to rearrange the equation as multiplying with 3 on both sides is 4x minus 2 or any other form like 3y minus 4x equals minus 2. All are acceptable. So this is equation of straight line where m is the gradient and c is the y-intercept. It says sketch the line. What we need to know is the previous exercise was on gradient. Positive gradient would look like this. This is positive gradient, and negative gradient would look like this. No matter where the line is placed, in which quadrant, the slope is thiswards when x is increasing and y is decreasing. And in positive gradient, no matter where the line lies, x and y both are increasing. That is positive gradient. So we know that gradient is positive, that is 2, and y-intercept is positive, that is 3 in this case. So x-axis, y-axis, I already know that the shape would just look like this, but it intersects at plus 3. This is the point of intersection, that is y-intercept. X is 0, y is 3. The next line, x plus 2y minus 6 is equal to 0. I'm rearranging, making y the subject of formula for better understanding. Let's say x plus 2y minus 6 is equals to 0. So 2y is equals to minus x plus 6. Then y is equal to minus 1 by 2x plus 3. Any disagreement in this, making y the subject of formula?
No, sir.
Okay. So I can see the gradient is negative and y-intercept is positive. So if we sketch x-axis and y-axis, negative gradient is negative slope, but intersecting at positive axis. So this is 0 comma 3 and the slope is negative 1 by 2. So this is the sketch. Now you can recognize two lines are parallel from their equation if they have same gradient. So we are looking at 1, 2, 3 lines. It would be easy to compare if we make y the subject in all three of them. Writing the first one, this is y is equals to 2x plus 7. In the second one, if we take x on the other side, 2y is equals to 2x plus 10. Then we divide by 2. So it will be y is equals to x plus 5. Now the third one, minus 3y is equals to minus 6x plus 9. Then we divide by minus 3. 6 by minus 3 is 2x and 9 by minus 3 is minus 3. So the third equation is y is equals to 2x minus 3. Now looking at the first, second and third, which equation do you think are parallel? 1, 2 and 3. What is the gradient of first line?
Gradient of first line will be just
General form. RS, this was the general form. Y is equals to mx plus c. Whatever is written with x is the gradient. So
two,
gradient of first line is 2. Gradient of second line is
one,
1. Gradient of third line is
two again.
2 again. So which two lines have same gradient?
First and third. First and third.
First and third. So first and third, these two lines are parallel because they have same gradient.
Yes.
Okay. So this is how we know the equations are parallel or not. 9.3a. For equations 1 to 10, find the gradient of the line and the intercept on the y-axis and then sketch the graph. I'm looking at the first one. I can see that the gradient is 1 because the coefficient of x is 1 and y-intercept is 3. So gradient 1, m is equal to 1 and c is equal to 3. And how will this sketch look like? Let's have some more writing space. Question number 1, y is equals to x plus 3. We can see the gradient is 1 and y-intercept is 3. So this is how it looks like. It passes through 3. You look at the second equation, that is y is equals to x minus 2. Again, I can see the gradient is positive 1 and y-intercept this time is negative 2. So the slope stays positive, but it intersects at minus 2 on y-axis. Luckily, from 1 to 10, all the equations are written where y is the subject of the formula. We didn't need to rearrange it. So look at 3. This is y is equal to 2x plus 1. Gradient is positive 2 and y-intercept is positive 1. So it intersects at 1 and the slope is positive. Similarly, y is equals to 2x minus 5. Gradient is again positive, that is 2, and y-intercept is minus 5. So it should intersect at negative y-axis where the slope is positive. Look at number 10. Y is equals to minus x plus 3. So gradient this time is negative. The slope is negative in the other direction and y-intercept is positive. So negative slope and it intersects at plus 3. Okay, now just try number 6 and then I'll sketch and we can compare if we are getting similar shapes. Try number 6. 1 over 2x positive gradient and 6 positive y-intercept. Done, Aris?
Almost.
You don't have to plot them. These are sketches.
Yes, sir, I know. But um, second do this one.
Okay. See, the gradient is 1 by 2. We are only interested in the sign. It is positive gradient and a positive y-intercept. The positive slopes are this direction and plus 6, so this is 0. And on top of that, it should intersect here. This is 6 and the slope is in positive direction.
Okay. Um, 6. Oh, okay. No.
Okay. Try number 7.
Sir, I sent you. Can check if it's correct.
This is y is equal to 3x minus 2. This is correct. So we have positive gradient and negative y-intercept. And yes, that is correct. Okay. Now look at questions 11 to 20. All the concept is same. The only difference is that we would need to rearrange the equations. Like the 11th is similar. This is similar. Let's try number 13. That looks different. So number 13 is y plus 2x is equals to 3. So I would rearrange it first. Y is equals to minus 2x plus 3. Now this is just like question 1 to 10. Negative gradient and positive y-intercept. This is how it looks like. Any doubt in number 13?
No, sir.
Okay. Try 15. 2y minus 3x is equals to 6. The sketch.
Sir, 15, right?
Yes. Done, Aris?
I am sending. Yes, sir.
This is correct. Only slight change. Don't write 6 by 2, write 3.
Oh, my bad. Yes, sir. 3.
Okay, now let's try number 16. 3y plus x minus 9 is equals to 0. Message page. Received. Okay. So when I would just rearrange, this will become minus x plus 9, and this is minus 1 by 3x plus 3. So negative gradient and positive intercept, that is correct. This is correct. Okay, so just try few more, or I would say just leave this and do 9.2 distance, midpoint, and gradient. Okay. because
Okay,
yesterday we
sir.
did a lot of practice with Ali. Hopefully, both of you will be on same level when we start our third class.
Yes, sir.
Anything you would like to ask?
No, sir. No.